Characteristics of a fuse, okay, very important. A fuse is a short piece of wire, short piece of wire with a low melting point. This statement is important. A short piece of wire with a low melting point. The fuse wire is made of alloy of lead and tin. This alloy melts at about 200 degrees Celsius. Okay, please listen. What do we get? What characteristics do we get here? A short piece of wire of low melting point. But keep in mind, no single metal fits this characteristic. All metals have high melting point, okay, high melting point, so no single wire will fit it. So in order to get a fuse wire, we use an alloy of lead and tin, okay. So this is a mixture of lead and tin in specific proportions, and when we have this alloy of lead and tin, this alloy melts at about 200 degrees Celsius, which has come down miserably from the melting point of single metal. So when excess current passes, it will if it comes to this limit, it melts, and when it melts, it breaks the circuit, okay. Point number 2, fuse wire is connected in series with the live wire. Alright, when we connect N to N, we call it in series. It has to be connected in series with the live wire. Its temperature rises faster than the connecting copper wires when an excessive current flows, as its resistance is higher than that of the connecting copper wires. Please listen, another characteristic is mentioned here, meaning it should have high resistance, okay, high resistance. Usually metals have low resistance to electric current, but we need high resistance. How much higher? It should be higher than the connecting copper wires. All right, so that means when we use copper wires for electrical connections, we should be having a fuse of resistance higher than copper wires. Why we want this fuse wire to be heated first and breaks before excess current passes into copper wires. That will save the connections in the circuit by having a fuse, okay. So it has to have high resistance higher than the connecting wires in the circuit. Point number 3, the thickness of fuse wire depends on the current rating of it. Higher the rating, thicker is the wire. It means that 15 ampere fuse is thicker than 5 ampere fuse. The heating of fuse wire does not depend on its length. It depends on the melting point, high resistance, and also on the thickness, okay. So we use thicker wire for higher current carrying capacity, all right, and a thinner wire, fuse wire for lower current carrying capacity, okay. So thicker is the wire, higher is the rating, okay. Then we go to miniature circuit breaker. In short, we call it MCB. A miniature circuit breaker is an automatic switch, okay, that is nowadays used to protect the household wiring from excessive flow of electric current in a circuit. When the current flow is in excess, the MCB automatically falls down to break the electric circuit. It is reset after the fault is rectified. Okay, this is automatic, okay. A miniature circuit breaker is used to protect the household wiring from excessive flow of current in the circuit. When there is excess current flowing in the circuit, this MCB automatically falls down by itself to break the circuit. Alright, it breaks the circuit on its own, and then it will have to be reset after rectifying the fault. Okay. Household electrical circuits. Each electrical appliance can be used separately. That is how we take the connections. Okay. Each appliance can be operated separately. Alright. Connections separate, operation separate. Okay. If one appliance fails, suppose now we are connecting a fan, we are connecting a fridge, we are connecting an electric iron, we are connecting the bulbs and so on. Then if one of these fails, then it does not affect the working of the other appliances in the house. Suppose a bulb fails, alright, it fuses off, then it does not affect the other appliances. Alright, all appliances work at the same voltage equal to the voltage of the mains. When we make the connections like this, then each and every one will operate at equal voltage, 220 volts. Such connection is known as parallel connection. So appliances in the household circuits are made in parallel. Alright. To get the appliances to be operated independently, they should be connected in parallel. This is what I mean. Hence, all appliances in our homes, schools, offices, etc. are connected in parallel. Each appliance has an independent path for current and works at the same voltage. Path is independent, but they work at the same voltage, like the voltage of the mains. Okay. Electricity is supplied to us at a voltage of 220 volts through a cable which has 3 wires, namely the live wire, the neutral wire and the earth wire. From the distribution board, electricity is distributed to various parts of the house such as the rooms, kitchen, toilet, staircase, etc. And each appliance get connected in this distribution board has a separate fuse and a separate switch. The fuse and the switch are connected in the live wire. Okay, what does it mean? It means in this household electrical circuits, electricity is supplied at a voltage of 220 volts as I have mentioned, and this cable has 3 wires, alright, the live wire, the neutral wire and the earth wire. Now, from the distribution board, electricity is distributed to the various parts of the house, the kitchens, the rooms, toilet, staircase, etc. Okay, but whatever connections we are taking, we take it from the same, we call it the ring, the main ring. Okay, we take it from the ring which goes all around the house, and then it comes back to the distribution board. An appliance will be connected in this distribution board. Okay, that means from the distribution board we have the ring and then it comes back to the board. So all appliance will be connected from the ring which is connected to the distribution board. But each appliance will have a separate fuse and a separate switch, and usually fuse and switch connected to the appliance should be in the live wire. Earthing of an appliance. The metallic outer body of each appliance is connected to the live wire. What does that mean? Remember, all appliances have the metallic case. Okay, now usually the metallic case has paints, so we need to remove the paints, and there is usually connection in the case, in this metallic case, for the earth wire. So the earth wire does not go together with the live under neutral wire in the appliance, but usually the earth wire is connected to the metallic case of the appliance. Okay, here is a reason. The reason is that sometimes due to breaking of insulation of wires, live wires come in contact with the body of the appliance and we get a fatal shock when the appliance is touched. What does that mean? Usually the live wire and the neutral wires, they are connected to the terminals which are provided for these, all right, the live and the neutral wires, and usually there is an insulating plug at the point where we connect the live and the neutral wires. Now, if in case, because of the breaking of insulation of the wires with the constant use, okay, then the live wire comes in contact with the body of the appliance, then what happens? High current will flow through the metallic case of the wires. Now, if we touch such faulty appliance, okay, if it is not earth, then a person will get fatal shock. All right, but if the appliance is earth, that means if the earth wire is connected to the metal case of the appliance, then the current will pass through the earth, okay, will pass through the earth, and when excess current will pass to the earth, that means there is excess current passing through this circuit, all right. So the fuse will blow off and then we remain protected from electric shock. So it's very important that a metal, the appliance to be earth, okay. Then power rating of appliance. Generally, an electric appliance is rated with power and voltage. For example, an electric bulb is rated as 100 watt, 220 volts. What is the meaning? It means that if a bulb is lighted on 220 volt supply, it consumes 100 watt electrical power. And still the meaning is this, that is 100 joule of electrical energy is consumed by the bulb in 1 second. Joule per second, remember that is watt, okay. So 100 joule of electrical energy is consumed by the bulb in 1 second, or in other words, 100 joule of electrical energy is converted into light and heat energy in 1 second. Okay, so that is the meaning when we say 100 watt, 220 volts rating. From the relation P is equal to V into I, from here I is equal to P by V, okay. So what is this I? I stands for the safe limit for the current in an appliance, okay. Hence the safe limit for current in an appliance is equal to power of appliance, this is power, by voltage at which it works, V, okay. So we have this relation by which we can calculate the safe limit for the current. Household consumption of electrical energy. The electric energy is sold in units of kilowatt hour. This we had discussed earlier. It is the unit in which the consumer pays the cost of electricity, right? The electrical energy consumed by an appliance in a certain time can be calculated in kilowatt hour by using the following relations, all right? Energy in kilowatt hour is equal to power in kilowatt hour into time, power in kilowatt, not in kilowatt hour, power in kilowatt into time in hour, okay. that is also equivalent to power in watt into time in hour divided by 1000, because it's not kilowatt anymore. This is in watt, so we divide it by 1000. Or we can also express it in terms of this relation. We can also have the voltage in volt, okay, into current in ampere into time in hour divided by 1000. So we use either of these to calculate the electrical energy consumed by an appliance, okay. Thus, the total energy consumed by an appliance in kilowatt hour can be calculated by multiplying its rating in kilowatt with the time. Alright, power in kilowatt into time, okay. Time, duration in hour for which it was in use. The cost of electricity will then be the product of energy consumed in kilowatt hour with the rate in rupees per kilowatt hour. Okay, so let's take this example to be clear. If an oven of power 3 kilowatt works for 2 hours per day, okay, then the electrical energy consumed by the oven per day will be equal to 3 kilowatt into 2 hours. Time is 2. This is the electrical power. So power in kilowatt into time in hour. Okay. So we will be getting 6 kilowatt hour. Okay. Now, while the electrical energy consumed in a month of 30 days, all right, 2 hours per day and we have 30 days. So how do we calculate? Then to get the time here, we have to multiply this 2 hours with 30 days. So we get, excuse me, 3 kilowatt into 2 into 30. So we get, this will be hours, okay. It will be 180 kilowatt hour. Now, if the rate of electricity is 6.25 per kilowatt hour, then we multiply it to get the cost for 1 month. So it will be 180 kilowatt hour into rupees 6.25. So that comes 1125 rupees. Okay. So that will be the electricity bill that should be paid. Alright. Are you clear? Okay. Then we go to the hazards or the dangers of electricity. Number 1. When you use a number of electrical gadgets connected in a circuit at the same time, suppose we use so many appliances at the same time, then a heavy current flows through the connecting wires, okay. In other words, the house circuits gets overheated. The circuit of the house itself gets overheated. There will be overheating of the electrical wires, because the circuit will be overheated, alright, which may cause short circuiting and even fire. So that is one of the reasons for short circuiting, alright. So this is the first danger that we excuse me, that we come across, okay, and that happens when we use many gadgets at the same time. Point number 2. Sometimes due to poor insulation of wires, the live wire touches the neutral wire. This causes short circuiting and the flow of current becomes excess. This excess flow of current damages the electrical appliances. Even the wires catch fire and there can be a mishap in form of electric fire. Okay. Poor insulation of wires. Alright. Each wire has its own insulation, but sometimes because we go for cheap wire, then it has poor insulation, okay. With the constant use, this poor insulation may break, so it makes the wire, especially the live wire, to become bare. And if that bare live wire comes in contact with the neutral wire, then it causes short circuiting. And excess current flows through the electric circuit itself, all right, and even through the appliances. So this may be the cause of mishap in the form of electric fire. Okay. Point number 3. If a person comes in contact with a live wire, he gets an electric shock. If it is a huge shock, it can cause death. Okay. Comes in contact with a live wire. That's why we need to know which is the live wire, which is the neutral wire, which is the earth wire. Because if we come in contact with a live wire, we can get an electric shock, and the degree of the shock depends upon how huge is the current flowing through the live wire. Precautions to be taken while using electricity. Very important again, all right? Number 1, we should not touch switches with wet hands. Just keep in mind, before you touch the switches, keep your hands completely dry. 2, the connecting wires to the plugs, sockets and switches should be tightly joined. No loose connections, okay? No loose connections. The connecting wires to the plugs, to the socket and the switches should be tightly joined. 3, we should ensure that all appliances are properly earthed. Okay, remember we have just discussed how do we do the earthing of appliance. That should be followed strictly, properly earthed. Then point number 4, we should not try to repair an appliance while it is in use. When it is in use, that means current still flows into the appliance. So we should not try to repair the appliance while it is in use. Point number 5, we should ensure that the MCB or fuse and switch are connected to the live wire. Okay. It's very important. If we make a mistake with this, fatal shock usually happens here. All right. All fuse switches should be connected in the live wire. Point number 6, the wiring must have proper insulation. Okay. Then the ordinary copper wire should not be used as a fuse wire because the melting point of copper is 1080 degrees Celsius. So it will not melt even if the current exceeds its safe limit. If we use fuse wire for copper, remember its melting point is very high, so it will allow excess current to pass into the circuit, all right? So that will be a danger for fire. Point number 8, to switch off the gadgets like TV, geyser, air conditioner, etc. Take out the plug from the socket instead of using the remote. Okay, so if we want to switch off the gadgets, any gadget, then we should take out the plug from the socket. Don't just use remote control and then leave it like that. Okay, so these are the precautions to be taken while using electricity. Thank you, children.